Stop. If your DB2 queries are crawling or your data is getting messy, you're likely missing two things. Today, you're mastering DB2 indexes and constraints, the easy way. Hey there, welcome to Topic Trick. I'm here to help you master database management, one step at a time. Today, we're diving deep into DB2 indexes and constraints. You'll learn how to speed up your searches, how to keep your data accurate with primary and foreign keys, and how to avoid the performance traps that catch most developers. Whether you're a student, a fresh grad, or an experienced pro looking for a refresher, this guide has you covered. By the end of this video, you will be able to design tables that are both fast and bulletproof. So, let's get started. First, let's talk about indexes. Think of a DB2 index like the index at the back of a massive textbook. Without it, if you wanted to find information on indexing, you would have to flip through every single page. That's what we call a table scan. With an index, you go straight to the letter I, find the page number, and jump right there. In DB2, an index is a separate physical structure that points to the data in your table. Here's the code to create a simple index. Create index ix_employee_name on employee, opening parentheses, last name, closing parentheses. This creates an index called ix_employee_name on the last name column of the employee table. Now, when you search for a specific last name, DB2 finds it instantly. A common mistake? Indexing every single column. This is bad. Every time you insert or update data, DB2 has to update the index too. This slows down your writes. Use indexes only on columns you search for frequently. Quick recap? Indexes speed up data retrieval. They're like a shortcut to your data, but use them wisely. Next up, let's look at constraints, specifically primary and unique constraints. A constraint is a rule. It tells DB2 what kind of data is allowed in a table. The primary key is the most important one. It uniquely identifies every row. No two rows can have the same primary key, and it cannot be null. Here's the code. Alter table employee, add primary key, opening parentheses, EMPID, closing parentheses. This creates a primary key on the EMPID column of the employee table. Now, what about a unique constraint? It's similar, but a table can have multiple unique constraints, while it can only have one primary key. Here's the thing to remember. In DB2, when you create a primary key or unique constraint, DB2 automatically creates a unique index for you. You don't need to create one manually. Pay close attention here. A common mistake is trying to insert a duplicate value into a primary key column. DB2 will stop you and throw an error. This is good. It keeps your data clean. Quick recap. Primary keys identify rows. Unique constraints prevent duplicates. Both automatically create indexes. Now, here's where it gets interesting. Check constraints. Sometimes you need more than just uniqueness. You need your data to make sense. For example, an employee's salary shouldn't be a negative number, right? A check constraint evaluates a condition before allowing data into the table. Here's the code. Alter table employee, add constraint check_salary, check, opening parentheses, salary, greater than 0, closing parentheses. This rule ensures every salary entered is above 0. If you try to insert a -5, DB2 will block it. This is how you build intelligent databases that protect themselves from bad data. A key takeaway? Use check constraints for business rules like age limits, date ranges, or status codes. Quick recap? Check constraints validate the actual value of the data based on your specific rules. Finally, let's cover referential integrity, or foreign keys. This is the relational part of a relational database. A foreign key in one table points to a primary key in another table. It ensures that relationships between tables stay consistent. Imagine an orders table and a customers table. You shouldn't be able to create an order for a customer who doesn't exist. Here's the code. Alter table orders, add foreign key, opening parentheses, customer ID, closing parentheses, references, customers, opening parentheses, customer ID, closing parentheses. This links the two tables. If you try to delete a customer who still has active orders, DB2 will stop you. This prevents orphan records from cluttering your system. Watch what happens if you forget this. You end up with data that doesn't match, and your reports will be wrong. Always define your relationships. Quick recap: foreign keys link tables and maintain the truth of your data across the entire database. Let's talk about some common mistakes you might run into when working with DB2. Mistake number 1, over-indexing. Here's what happens. Your select queries are lightning fast, but your insert and update statements are incredibly slow. Here's the fix. Periodically review your indexes. If an index isn't being used by your queries, drop it. DB2 provides tools to see index usage statistics. Mistake number 2, null values in columns that should be constrained. Why this happens? Beginners often forget to add the not null clause when creating tables. How to avoid it? Always define your columns as not null if the data is required for a constraint to work properly. Mistake number 3, not naming your constraints. The quick fix? When you create a constraint, give it a clear name, like check_price. If you don't, DB2 will assign a random system name. When an error pops up later, you won't know which rule was broken. If you run into any of these, don't worry. It's a normal part of the learning curve. Just take a breath, check your alter table statements, and you'll be good to go. Let's quickly recap what we covered today. First, we looked at indexes and how they act as a shortcut to speed up your searches. Then we mastered primary and unique constraints to prevent duplicate beta. After that, we explored check constraints for enforcing business rules. And finally, we discussed foreign keys and how they keep our table relationships healthy. You now know how to optimize and protect your DB2 databases. You can write cleaner code and design better systems. That's a lot of progress for one session. Give yourself some credit for leveling up your skills today. If you found this DB2 guide helpful, hit that like button. It really helps others find this tutorial. Subscribe to Topic Trick for more programming and database tutorials just like this one. Drop a comment below and let me know which DB2 topic you want to see next. That's it for today. Keep practicing, keep coding, and I'll catch you in the next one. Happy coding!